It is a great pleasure to welcome you at this event on water and globalization. Now, the date chosen by the organizers, Carlo Giupponi and Hilda Mannino, has not been chosen by chance. The 22nd of March is probably, many of you have heard, is the World Water Day. And what we want to celebrate today is awareness of the importance of fresh water and the sustainable management of fresh water. Also, we should mention that 2013 is the International Year of Water Cooperation, and so it is, just very appropriate that we should celebrate this at VIU this year. Let me just say a few words for those of you who don't know about VIU. It is an association of international universities and other bodies, amongst which the Italian National Research Council, CNR, and the Italian Ministry for the Environment, Land and Sea. So, it fits very nicely with our topic today. It is many years that VIU has been working on sustainability and on challenges that emerge from climate change and so on. And this is mainly due to the relationship with Ca' Foscari University. As you know, Ca' Foscari is a leading partner at VIU and is also where, the core of the research on these topics is going on. And this leads me to thank very much my colleague Carlo Giupponi, because he came up, when we discussed about what we can do about water, he came up with this idea, and immediately VIU and the International College embraced this idea. And I must say, I'm really amazed that in basically 2 months, VIU, the International College, under the leadership of Carlo Giupponi, managed to put up such a nice and interesting event. So I just want to welcome all of you and say how much I appreciate your presence here today with the strike and everything. So I'm sure it will be an extremely successful meeting. And I'm particularly pleased for another reason. This is one of the first occasions when we have together VIU students and international college students, and I hope this will be, like a sequence of these events, because this is the wealth of the island is to have the students around and have participation to these events.
Good morning to everybody. I want to thank the organizer for inviting me to talk about this important topic for us, and we started working on this subject since 2005. So I'll try to tell you something about what we have done in Nicaragua and Guatemala. In particular, it has been recognized that the biggest problem that those, in particular, both Nicaragua and Guatemala had was do not have access to water, in the sense that water was sometimes very far, and so the availability for families in rural areas was very, very short. So we made a questionnaires as a project, and they recognized that the priority was the drilling of wells in the nearby of families for favoring the development of that rural areas. So the project, more than one project actually, because we started near 2005, concentrate on two solutions to improve the water access. The first one was where some existing wells were already drilled, obviously, we proposed the utilization of an EMAS pump. And the other one was to increase the number of wells with a very simple technique, that is the Bolivian Baptiste technique. And then on that wells, we proposed the utilization of the EMAS pump. The collaboration of the University of Florence and in particular the Department of Agricultural, Food and Forestry Systems started, as I said, in the year 2005 in Nicaragua, and it went on for 5 years over there in the Department of Leon. And the involvement of the University of Florence was with one professor that went there more than 4 times. Then we have one student there with a scholarship, and then another student that spent some months over there for his thesis. The project was in collaboration with some ONG, Italian ONG, so COSPE and AUCS, that is a University Association for Cooperation and Development, the Tuscany region, and the University of Florence, of course. It was already, at that time in Nicaragua, in that period, it was running an international agreement with the Universidad Autónoma Nacional de Nicaragua, in Managua, but now it's expired. So the university over there is not anymore involved in this subject. The activities that has been carried out by the University of Florence and obviously also by some of the other people from the ONG was field assistance in pump making, construction, and well drilling, the transferring of the technology for for constructing the pump and for drilling the well, and the final part, that is the monitoring, because we recognize that obviously it's not enough to involve workers and to let them work with people that have more experience, but what is lacking sometimes is the final step, final phase of assisting after some period, because otherwise they will not continue in using the pump, or more, they do not know how to solve or to fix some problems in the pump, and so they stop using. In 2011, another project starts in Guatemala that is now ongoing, and the department is the Department of Sololá in the municipality of Sololá. And from University of Florence, we got one professor that went there for some times, and more than 3 times, and 2 students that stayed there for more than 4 months. So we had assistance on the field to workers, to families in rural areas. The institutions that was and are involved are 2 ONG, Oxfam and Africa 70, and the University of Florence, through which we had finances for let students stay there for 4 months. We had an international agreement still running with the San Carlos in Guatemala University, and in particular for with the Centro Universitario de Oriente Cunori in Chiquimula. Through these exchange students, we got the possibility also to invite some students from the Cunori, and they spent 3 weeks at the University of Florence. And we got seminars for these students on this technology of well drilling and EMAS pump utilization. The activities that has been carried out have been the same of the previous project. Has the number of pumps and wells that has been drilled in Nicaragua, we installed 80 pumps, and we drilled 64 wells. So it means that the 20% of that pumps has been installed in already existing well tank. We had more than 150 workers that got involved in the preparation phase of the pump construction and the well drilling. And all these pumps covered, let's say, it's an area of 300 square kilometers. In Guatemala, the situation was like more different because the number of pumps obviously is less because also the time running up now is much less, but there were a lot of existing wells, and we suggest them to move to this kind of pump that is, we will see that is an hand pump that is quite easy to be utilized and without any cost of running, let's say. So the drill wells was 35%, 18 on 52. A course at the site has been run on for transferring the technology, but just because we wanted that these 20 workers would have spread later on the technology in the area. So we had two kind, let's say, of formation: one in class and one on the field. And added to these 20 people, we had workers that work with us, let's say, for well drilling and pump realization. And the area that has been covered, let's say, is roughly 100 square kilometers. The department of Sololá is in the south part of Guatemala, and there is a touristic place, that is the Lake of Atitlan, that is the most important attraction of this department. And the study area, the area where we worked was the municipality of Sololá. So let's go and just talk a little bit about EMAS pump. EMAS pump, EMAS is an acronym, and it stands for Escuela Móvil de Agua y Saneamiento, and it has been proposed for the first time at the beginning of the 90s from the German Wolfgang Buchner. The pump is a piston pump and working, and as you see here, it's made up of very simple material, in the sense that this material can be found very easily at the site. So we don't need to bring anything from abroad, but we can find the material at the site. And this is a very important aspect for the project, because even if when something is got wrong in the pump, we can fix at the site without making any kind of transportation. So PV pipes and pipe fitting, galvanized iron pipe, glass bolts, and car tire. These are the list of the material that are needed. Obviously, we need also the equipment for putting together all this stuff. This is the scheme of the pump. You see, it is made up of a fixed part and one mobile part. The fixed part is 1 inch PVC cylinder, and at the bottom it has the foot valve, and the bottom of this part is in contact with the bottom of the well. The mobile part is made up of two portions, let's say. One is PVC, and at the top we have the galvanized iron pipe. We had at the bottom of the mobile part the other valve, that is the piston valve, and the water is coming out from here. So the water goes up to here and then goes out from this portion. So the mechanism is very easy because it's just the movement of going down and rising up of the mobile part that recalls the water within the pipe and make it going out from the one extremity of this T pieces. The two valves are, the foot valve and the piston valve are the most important part of the pump itself because it is the place where the functioning is concentrated, because when it goes down, the foot valve one is open and one is closed, and when it's rising up, it's vice versa. So this is the result of a drilling of a well with the Baptiste technique and the installation of the EMAS pump. So what we see from outside is this portion. And this is the last part of the pump, and then you go up and down with this. So it can be utilized by men, women, children, and so on. And from here you take water. In this case, the application was for domestic use. So this pipe was going with in the house. Important thing is to close this part because we don't want to have any contamination from outside. You see here that very often we have animals here. We have animals in the nearby, so try to fix this part and to let be sealed. It's very, very important for protecting, let's say, the water quality. And very often the well has been located for being used by more than one family. In fact, in this case, 3 families had access to this well. And this is important also because more people can have the possibility of if the utilization is from more than one people, you take care more on the pump. And so here you see the utilization for domestic use. So it is not the only utilization. We had also some utilization for irrigation, but mainly is for domestic. Here is the pump that we have made in the laboratory, just for showing to our students how the technology is. And this has been very, very interesting because we show to the student and they contribute to the realization of this pump, and obviously in the lab the time for constructing the pump, it was 1 hour and a half. Obviously at the site you take more time, but the materials and how to put together all the material is very easy, and so also students appreciate very much. Here is the one of the valve that are used in the mobile and fixed part. And you see here the glass ball that goes up and down due to the rising up and going down of the mobile part. That is the function has piston. It is the same. The color of this pipe is not. I mean, in Guatemala and Nicaragua, it was white, and in general, I'm not utilize this marble glass, but marble ball, sorry, but glass ball. These are too expensive for them. I mean, it's not very commonly utilized. So As regards the monitoring that I said is very, very important, the project carried out some kind of testing of the performance of the pumps. So we measure the extracted volume before the maintenance operation, then the extracted volume after the maintenance operation. We characterize the extracted water not only in some well, some chemical analysis has been done, but just for see if the material, if the water was clear or enriched with a solid inside. And the maintenance operation has been carried out with the pump users. So the people that were involved in maintenance and utilization of the well and the pump tried to solve the problems, even if they didn't know which was the problem, but they fixed the problem. And you see here that these are some workers that made the testing of the volume extracted. So the number of tested pumps in Guatemala were 52, so the monitoring has been done on all the 52 pumps that has been installed. And after 1 year, the number of functioning pump was 42 out of 52, and the performance of the 42 was more than 93%. So it means that they were functioning. We should spend some words on what we define as performance, because obviously the amount of water that you can get from the pump depends on the frequency of the rising up of the mobile part. So we fix the excursion to a height of 45 centimeter, and we fix at 50 pumping per minute. So with these two characteristics, we can get 15 liters per minute. So the performance is in the sense that how much is the difference between what you get and these 15 liters per minute. One problem is the fact that these people do not care on how much water they get. So for them, the performance is not a problem because they just take more time for having the same amount of water. But the problem is that this, if it's not functioning correctly, then maybe in some time the pump could not function anymore. So what we try to tell them that is it's important to try to verify or try to control if it's working and make some kind of measurements of discharge, because otherwise in a short time maybe the pump is not functioning anymore, and then problems would be more bigger problems to be fixed. Coming to the end, I just put here some points for try to outline which are the strengths, the weakness, and the opportunities and the threats. So the strengths of this technology is related to the simplicity of the functioning, in the sense that, first of all, the material can be found in the place, and this is a great advantage. You can pump water up to 40-meter depth. The cost related to the installation of the pump is quite low, because obviously it depends if you have to buy all the equipments, or if you have, or if you share the cost of the equipment, so on. But in general, if you have the cost related to the one installation is roughly $50. It can be hand operated, so all people can take its home water, children, women, and so on. Can be easily repaired because it is made up of simple material, but the problem, as I said, is that sometimes they do not know what is wrong. You can pump also water and stock in a reservoir, and so can be used, for example, in another time, or can be used for other uses, like irrigation. So they had sometimes drip irrigation just because they utilize this water in a reservoir. And also the quality of the water is a little bit improved in the sense that you don't have local contamination. So obviously we may have problems of water quality due to aquifer pollution, and they have in Guatemala, but we don't have contamination locally. Okay. Weakness. Lack of interest in recognizing low pump performance, and I said already, and it's very important, and we recognize this weakness in the monitoring phase because there is a lot of interest when you propose the methodology and you teach them how to do that, and they do it with you. But in the long term, the problem is that they have the pump, so they don't care anymore. So we should be aware that also the acquired competence on the field, so like with the formula training on the job, should be tested. So we had, for example, some pump made without any influence by us. They just let them working. And differences in time needed for a pump installation. This is just less. Opportunities is the collaboration between people over there, because the technology is going from one village to another one, so the people that has been trained in one village become the trainer of the other one. And this is very, very important, because in the field of cooperation, our involvement is going to be reduced in time if you train very well. Improved water quality for human consumption, and some problems may arise, for example, when we are not available hydrological map, because sometimes we need to drill a well in a place just because people told us that it's needed, but we don't know at which depth is the aquifer. So in that case, or either the strata that you can find, because the drilling with the Baptiste technique is going to be, and the results are going to be reduced if you find a rock stratum. So the lack of this kind of information sometimes represents a stop of the procedure, because you start drilling, but sometimes you stop because the rock is too hard or you can't go on. And the other one is related to the groundwater quality and quantity, because in the same way, if we don't have enough data, sometimes we got the water, but the quality is too bad, or either you have too much differences in the water table or the piezometric surface, depending on which kind of aquifer we have, during a season. So sometimes you arrive to a depth and then you got not water during the dry period. And difficulties in well drilling in the presence of rocks. I mean, with this Baptiste technique, you can do it, but it depends on how much is the depth of the height of this stratum. So the key message that I want to share with you are related with the role of cooperation project in the field of water access. So we are trying to spread, let's say, the technology and the way of have this access to water with these two combined technology. The utilization of appropriate technology, because these are technology or these are instrumentation that are very easily to be prepared on the field. And this is, I think, the most important message. The other one is the technology transferring. So we should, and a participatory approach run together, because one key issue is to involve local people, but not only the users, not only the workers, but also municipality, because they should be aware that we can improve situation of water access in rural areas with very simple methods. So technology transferring, but do not leave, try to do not just teach them how to do that, but formation, but training on the job. So both should be applied. And as I said, participatory approach just for the first step. So people should tell us where they need water. So they could be around the 3 or 4 houses. It could be in a school. It could be close to a church and so on. But they should tell us where to drill. Now, and for that point on, we should take into consideration the possibility of the feasibility of drilling in that place, but they should tell us. So this is an involvement just from the beginning. I think I can. Thank you.